In this college algebra section, we will be discussing inverse functions. Please press pause and read the objectives. All right, the first thing is, what is the inverse of a function? In order for two functions to be inverses, that means that the f composed with g will equal x, and g composed with f will also give me x. So in this case, if that does happen, then g is the inverse function of f, and instead of denoting it as g, we're now going to call it f to the -1 power. That is not a -1 power, though. That is a superscript, so that means f inverse. So please get those. Please make sure you don't get that confused. So f composed with its inverse is equal to x, and the inverse composed with f will also give you x. So that's the algebraic way that we check our work to make sure that we have done everything correctly. So let us verify that each of these functions are in fact inverses of each other. So we need to show that f of g of x is equal to x, and we also need to show that g of f of x is also equal to x. All right, so let's start with this one over here. So we're going to start with our function f, which is 4 and then x minus 7, but instead of x, we're going to put x plus 7 over 4. We're going to put that function g. So notice the 4's will divide out. I'm left with x plus 7 minus 7, which is just x. So that one checks out. But the second one must also check out. So please don't stop when you're done with this first one. Think, oh, the other one must work. It doesn't always work. So you're going to start with your function g, which is x plus 7 over 4. And inside of it, you're going to put your function f, which is 4x minus 7. So notice in your numerators, your 7's will add up to 0, and you're left with 4x divided by 4, which is x. So they do check. So these two are indeed inverses. And that is how you will check your work later on. You will have to go through this process to make sure that you're double checking. So if you want to find the inverse and they don't give it to you, you will need to, step number 1, replace all your function notation with y. Step number 2, you will interchange your x and your y. Step number 3, you will need to solve for y. If this equation does not define y as a function of x, then the function f does not have an inverse and the procedure is over. So just know that if you can solve for y, then it's going to have an inverse. If you cannot, it does not. And then step number 4 is, again, just double check your work. So go back and make sure that both compositions are both equal to x when you are done. All right, so here we go. We need to find the inverse of f of x equals 2x plus 7. All right, so first thing I'm going to do is replace my function notation with y. So that's step number 1. Step number 2, you're going to switch the x and the y. So every place there's a y, put an x. Every place there's an x, put a y. All right, step number 3, solve for y. So x minus 7 equals 2y, and then I'm going to divide everything by 2. So x minus 7 over 2 equals y, but instead of y, I'm now going to write the inverse of x. Okay, and then if you want to check your work, you will need to go back through and make sure. So for the check, you are going to compose, right, the function with its inverse, and that should equal x, and you should compose the inverse with its original function, and you should get x. So that's what you would do to check. You would do all that algebra we just did in the last example. All right, an easy way to tell if a function has an inverse is if you have the graph, is just to do what's called the horizontal line test. So the vertical line test that we talked about in an earlier lesson discussed how we could find out if a graph was indeed a function, and the horizontal line test tells you if we can have an inverse of that function. So if there is no horizontal line that intersects the graph more than once, then you're good. If the horizontal line intersects more than once, it will not have an inverse. So let's look at these two graphs. Let's look at A. Okay, is A going to have an inverse? And it is not, because it's 2 spots, right? It fails the horizontal line test. But if we look at C, excellent. We will have an inverse because it only hits once. So that's an easy way. I like the horizontal line test. Very useful, just like the vertical line test was useful. All right, if you have a graph, what if they give you the graph? What if they don't give you the equation of this graph? What if it's a piecewise function? Can we find its inverse? The answer is yes. It turns out that f and its inverse are reflected over the line y equals x. So this means that the coordinates will just be flip-flopped. So if you have the point 1, 2 in your original function, that means the point 2, 1 will be in the inverse. So you can just take those and reverse your coordinates, which makes things quite easy. So let's do an example real quick. All right, so I have a little piecewise function over here. I put the chart of values over on the left because I find that to be very helpful. And if you want to find the inverse, all you have to do is reverse those coordinates. So notice they're exactly the same here, which means, okay, so let me give you some pointers. The point -2 lies on the line y equals x. So because it lies right on the line, if you reverse it, notice it stays exactly the same. Okay, because remember, when we do this, it's going to reflect over this line right here, right? This line. Y, that's the line y equals x. So it's going to reflect over that line. So notice because it's on the line, it should still be on the line. Okay, this point will become 0, -1. So 0, -1 is right here. Notice how it's reflected over the line y equals x. And then the point 1, 2 will become 2, 1, 2, 1 right here. Notice how it's reflected. So there is the graph of your inverse. This is y equals f inverse of x. So graphically, I think these are a lot easier to find than they are algebraically. So it's the one time that I actually enjoy doing graphs. So hopefully this helped you out. Please go back and practice, and I hope to see you in the next lesson.